Do we want to talk about the homework or the questions?
I'm okay jumping into the quiz. I'm okay on the questions, but we can talk about the questions if anybody wants to.
Yeah, I got it, except it was like re-getting it again.
Yeah, I agree.
So it just took me a little while longer. But talk more about everything. So review and review and review.
Except there was new stuff too, though. It kind of was a little bit of a review, but then there was new things. I don't know about you guys, but I find the homework assignment more helpful than the questions. You know, that what's it called after the lesson?
Yeah.
The preparation assignment, I don't find that all that useful, but the homework seems to be. That's when I really feel like I'm kind of getting it, I guess.
Yeah.
The only question I really have is the X bar symbol. I'm feeling like I'm not getting an exact definition of what that is. Because I think it's the sample mean, right?
Yeah.
But then they've called it a random variable before, so I don't know. I'm just a little bit confused by that. It seems to function like the mean, you know, in the equation. It just replaces the mean. So
yeah, it's sample mean, and then I guess it could just be any value represented.
You said Z bar, right?
the X bar. Yeah.
Okay.
The Z bar is just the Z score for the sample mean. Yeah, I think we got that figured out. But the X bar, I think, is the sample mean, but I've heard it called a random variable or a value, too.
Yeah.
That's a great question.
Well, I'm just going to assume that it just means the sample mean for all intents and purposes.
I would do, but if you want, I can ask the tutor.
Have you had any sessions with the tutor?
Not yet, but I feel like they're coming up soon.
Okay, well, should we jump into the quiz then?
Sure.
Yeah.
Okay.
What's the website for that?
The applet?
Yeah.
Let me look on mine. Let me open it up and look what it says.
If you Google BYUI stats applet, it'll come up.
My
Google what?
Or statistics applet, and it'll come up like BYUI options. It's come up every time I've done it. But if you go into in the wiki, you can't use theirs. Haha, never mind.
I can give you the URL if you want it.
Yeah.
Okay, ready?
Uh-huh.
Okay, it's byuimath.com /apps, APPS,
Okay.
/NORM, like normal,
Okay.
prob, PORB, .html.
Okay, got it. Thank you.
Okay.
Sorry for the delay.
I just know it. That just reminded me I'm going to open it up on my screen and my calculator too. So I got both of them ready to go. Okay, so let's see.
Are we ready?
Yep, I'm ready.
Sweet.
Oh, well, here we go. Number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of a z-score of 1.358 and to the left of a z-score negative 1.358. So we need everything to the far left or the far right. And then combine it.
So everything between the far left and the far right, is that what you said?
Well, okay, if you put in the z-score on both of them, one of the left side is negative and then the right side is positive.
Right.
And then you highlight the far sides.
Oh. Then our result is 0.175? Or did I do that wrong?
No, that's what I got.
Yep. Okay.
So 1, 7, and then just round to 3 decimal places, so it's 175.
Yep.
So, okay, is everybody okay with that one?
Yep.
Yeah.
Okay, who wants to take number 4?
I will.
Okay.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. And as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean as ours in the positive direction.
So that means like the previous applet we just did, the far left and the far right, right?
Yeah.
Okay. So first we need to find the z-score. Is that how you guys are seeing this?
Yeah.
Okay. So
Now this is just the normal z-score, right? Without the.
do we have a sample? No, we have a sample, 48.
Okay.
48 passengers.
Okay. So what do you put? Oh, never mind. Never mind.
No, stay on the page. Stay on the page.
So has everybody got the Z-score yet?
No.
Okay.
Almost.
Do you need help finding it, or are you okay?
I think I'm okay. I'm almost there.
Okay.
Okay. I got negative 1.920.
That's what I got.
That's what I got.
Mm-hmm.
Sweet. I was panicking for a minute. Everything I learned went out the window. Okay.
So if we put that into the applet, okay, I get 0.0549.
That's what I got.
Yep.
Wait, what?
So you're going to put negative 1.920 in the bottom square,
The left side.
right?
Yeah, I just put the wrong number in accidentally. What was the area did you guys get?
0.0549. Did you highlight both the left side and the right side and nothing in the middle?
Yeah, something's weird. Maybe I need to refresh my applet. Okay, so the C-score was negative 1.920.
90.
I can't hear you.
Negative 1.920.
Yeah, I didn't put the 9. There we go. There we go. 0.0549, right?
Yep. Okay, so we're supposed to round to 3 decimal places, so that'd be 1, 2, 3. So we have to round up. So 0.055. Is that right? These boxes scare me. I wish it was multiple choice instead.
Yeah.
Because I feel like if it's not exactly precise, then it's going to be wrong. Even if I had the right answer.
Yeah. Okay, I'll do 5. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, the distribution of the sample means X. This cannot be determined from the information given.
Oh, I don't even understand this.
So
A smaller standard deviation. 9 observations are randomly drawn. Well, it's not big enough to be a large sample.
Yeah.
Distribution of the individual observations.
I don't know. Could you really estimate that? Like, is that even, because it's 9 of them that are picked randomly.
Yeah. So it could have a large standard deviation, or large deviations between those randomly drawn samples. And it's not a large sample, so we can't say the distribution would be you know, match the parent population and be, you know, smaller. Which of the following will have a smaller standard deviation? I'm leaning towards the cannot be determined.
That's what I was thinking.
Because it's not, you can't use either of the rules about, you know, large numbers or the central limit theorem. You can't really use either one of those, I don't think.
The only note that I have, like, kind of talks about that. So it says it, when it's normally distributed, is the spread. Okay. Standard deviation of the distribution of sampling means would be smaller than the standard deviation of the population by a factor of 1 divided by the square root of the sample. That's all I have. No idea.
Those were too tricky. Because it's.
What do you think, Kristen?
I think it cannot be determined.
You know, you could have put us out of our misery like 2 minutes ago. No, I agree. I don't think we can determine it. Okay. Are we okay with that?
I can't hear you. It's like breaking up.
Oh.
Say it again.
No, I was just wondering if we were ready for question 6.
Oh, well, what are we going to put for 5?
Oh, I thought wait, is it, do you, well, I think it's that it cannot be determined personally.
So do I.
Okay.
Because the first one is talking about the individual observations, which is X. The second one is talking about the distribution of the sample means, which is X bar. Those are two different means. Or actually, the first one's not even a mean. And the sample size is not large enough to say, oh, yeah, it's fine. It's the same as the, you know, parent population.
It's just like the question is asking, like, which one will have a smaller standard deviation? And there's really no way of us knowing what the standard deviation is unless we see data or we see how large it is or how small it is.
Yeah, we don't know the standard deviation. We don't know the mean. We don't know the size of the population or anything. So
yeah, And I also think like it's only 9, what is it? 9 observations, and they could be complete outliers. There could be no correlation. So
Yeah.
Okay.
I'll go first. I'll take the hit.
All right.
So we're moving on to number 6.
Yes.
Yep.
Okay, so which of the following results implies that the spread in X bar decreases as the sample size increases?
The
The spread decreases and as the sample size increases. Isn't that the law of large numbers?
Yeah, because it's talking about the spread.
Yeah.
I agree. I don't know what to say, so
Yeah.
I'll just say I agree.
I think it's a law of large numbers.
What did I?
Because it's the central limit theorem that talks about the shape of it, right?
Yes.
Yeah.
Say the law of large numbers describe what happens to the spread of the distribution of the sample means when the sample size is large. So it only makes sense that when it gets larger,
The distribution gets smaller.
yeah.
Sweet stuff. Okay, I can read number 7.
Okay.
Scores on the quantitative portion of the... Oh, wait. Is everybody in accordance with number 6?
Yes.
Okay. Okay. So 7. Scores on the quantitative portion of the GRE... Ugh, I have to take that soon. Are approximately normally distributed... Yeah, it's terrible. Are approximately normally distributed with the mean of 150.8 and standard deviation of 8.8. Uses information to answer questions 7 through 10. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Round the answer to 3 decimal places. Blah, blah, blah.
Okay, so there's no sample, right?
Yeah.
So we just need to figure out her Z-score.
Right.
Okay. Did we get it?
Almost there. Okay, I got 1.04545.
Yeah.
What everyone's got?
Yeah, that's what I got.
So we're rounding to 3.
Wait, what did you get again?
1.045.
Okay. Okay, good.
So for number 8, What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? We just put it into the applet, right?
Yep.
And so it's above, let's see, so what section is it going to be? It's going to score above 160. So just the far right section will be highlighted?
Yep.
So it's 0.148.
Yeah.
Yep.
Can you guys hear me?
Barely.
Barely?
I can hear you, but it's not really loud.
Okay. Let me move my phone closer. How's that?
That's better.
Okay. So did you get 1.045 for 7? I didn't hear that one.
Yes. For number 7,
Okay.
it's 1.045.
Okay.
And then for number 8, we just put it into the applet. I don't know if you heard that too. Okay.
Yeah, I got that one. Thank you.
Woohoo!
I have a feeling the probability thing is going to be like really important for the rest of the class, because that's what people want to know. What's the probability of such and such happening? I just feel like we're gonna be having to do that a lot.
Yeah.
Okay, let's do 9.
Probably will. Okay. Who wants to take number 9?
I will.
I can.
9. We're on 9.
Kirsten, you can.
Okay. Okay, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? So for this one, you got to find the mean first of the 5 scores, and then plug it into the z-score formula.
So we don't have to do each one individually, right? We just find the mean of all the scores.
Yeah.
And then find the z-score?
Yeah.
Okay.
It's 160, or the mean is 160.
Okay. Okay, am I totally...
Okay, I'm confused because I don't know what...
Are we taking the information from number 7? For problems?
Yes.
Okay, I'm going to say that I don't have the standard deviation. 7 through 10. Okay, yeah. So use this information for questions 7 through 10. Okay, that's better.
So we're doing 160 minus 150.8.
Yeah.
Can you repeat that?
So we're doing 160 minus 150.8
Yes.
Mhm.
over 8.8 again.
This one has a sample size of 5 people.
Oh, gotcha.
So it'll be 8.8 divided by.
The square root of 5.
Yeah.
Okay. Okay.
What did you guys get?
Yeah, 2.337.
Woo! Yes. Wait,
Okay.
did everybody get that before I start celebrating?
Yeah, I got 2.3377, so that would be rounded up to 2.338.
Yep.
Yep.
Did you get something different, Eloisa?
Nope, that's what I got. It's a
All
good
right.
feeling. Okay, I can do number 10 if we're ready to move on.
I just need to put my answer in.
Okay.
Okay, I'm ready to move on.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So we pretty much did the same thing we did before, right? With the applet.
Yeah.
Oh, yeah. I was thinking we already did that, but so use a z-score of 2.338.
Mm-hmm. And then we only highlight the right part, right? Because, what is it? That's what they're asking?
Yes.
Greater than the mean achieved?
Yeah.
And I got 0.0097.
That's
Yep.
what I got too.
What? What did I do wrong? You put in 2.338?
Yeah.
No. Oh, yes.
And only highlight. Well, okay. I'm feeling a little bit confused. The probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem. So I'm just going to look at this. If it's greater than the mean, is it correct to only do the little tiny portion to the right?
Mm-hmm.
Yeah.
That's like 2 standard deviations away from the mean.
Yeah, that's greater than the mean, though.
Because if they were supposed to do, if it's less than the mean, it would go into the negative side.
Right. But, I mean, just looking at this graph, the mean would be at 0, right?
No, not necessarily. If you think of a histogram, your mean would be the high, like, I don't know how to explain this. Kristen, you take it away.
So the z-score is representing the mean in this case?
Yes.
Yes.
Okay. Well, that makes more sense. I don't know. Well, just seems like it should be at 0 if it's the mean. All right. I'll go along with that. Okay, so we've got
0.0097.
That's the probability. Okay.
$11?
Okay, who wants to read 11? Is it my turn again?
I think so.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.07 or 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Use information for problems 11 through 15. So it is well known this distribution is left skewed. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of 81 students who were selected? So is it going to be left skewed like the parent population, or is it going to be normal because it's a sample of 81, which is over the large?
I think it would be approximately normal because it does have the sample of 81 students.
Yeah, I think so too.
I second that motion. Chrissy, you don't look so sure. Is she still there?
I don't know. Christy, can you hear us? She looks like her screen looks frozen.
Yep, it does. It's kind of a funny thing to have be frozen too.
I'm sure she wouldn't appreciate that.
No, I wasn't trying to be mean.
It always freezes on the least flattering thing, right?
Always.
Yeah.
I was watching a talk by Elder Holland the other day, and it froze like in mid-sentence, and I was like, that's the only time I've ever seen anything freeze appropriately.
No, I don't want to start this over again.
Can't she join it again?
She's still there, it looks like.
Maybe it's just frozen for a moment.
Okay, so we're going with approximately normal for 11, right?
Yes.
So hopefully we'll get back voluntarily.
Oh, she's trying to call in.
I don't know how to answer it.
Dang. How do we invite her?
I'm sending her the link.
Okay.
I could send her an invitation again, but I don't know how to answer it when she was calling. I'm afraid to that I'll cut you guys off.
Well, here's the thing. She's got to leave the call.
I'm gonna try calling her because that didn't interrupt anything before. There, I just invited her. She's probably got 3 calls going now.
Perhaps.
Oh, crap.
We only have 4 questions left, guys.
I know. I don't want this to mess up.
Well, in the worst case scenario, we could always continue and finish it, and then she can watch the video.
Yeah.
Yeah.
She's messaging us now.
Can anybody answer that? Because I don't...
Wait, I think I was the one calling. Yeah. Wait, I think I was going to try to get her calling. Okay. Why isn't the system easier to manage?
I don't know. It seems strange she couldn't just rejoin without...
There we are. Hold on. Answer. Answer. Oh, snap. I think I'm going to...
I don't know how to answer it.
I think I answered it. It's not gonna let me answer.
Probably because I initiated the call, and I don't know how to answer her. Usually it comes up some indicator,
you know. The call?
Hi. I can hear that you're calling or trying to join, and I don't know how to answer it though.
I think she has to actually...
Oh man. Did you because I sent you another invitation to try and join. Did you see that one? Yeah. But it wouldn't work?
I think what needs to happen is that she needs to get on the invitation, on the little chatting thing. You know how the chatting box comes up and it says you've been invited? There's a sign, there has a little camera sign there, and it already states that she's here. She needs to just go in there again, I think.
Are you talking about on the invitation? Or because I'm not even sure she's getting to this screen.
Oh. Well, maybe does she want to just be like, can she put us on speakerphone or something? And she could listen to the rest of the phone call or the...
Well, how about this? We'll just finish it and submit it, and then I'll post the link, and then you can see the rest of it. And then if we can maybe retry the call if we want to work on the homework quiz, because I don't want to mess up this recording. We'll just finish it real quick, and then I'll stop the recording, and then we'll just retry the call. And we can just go to Google Hangouts. We won't even have to do this, because it'll just be the or you can just stay on the phone if you want, and I'll tell you what we're getting.
You can put her on speakerphone and she could
do that. Yeah, I can just, well, yeah, I'll just stay on the phone. And okay, she says she's on 12. Let me go back to my quiz. Yeah, we're on 12. So did you, we decided approximately normal for 11. Are you okay with that? Okay, she said it's fine. On 11, so 12, what is the mean of the distribution of the sample means for all possible sample sizes, size 81 that could be drawn from the parent population? So the mean of the means is the same as the mean, right? That's that same old question?
Yes.
So it would be 81.
No.
No?
No, that's your sample size.
So what is the mean?
The mean would be
3.5.
Yeah.
Okay, 3.5. Sorry, I just looked wrong.
Wait, what? I don't think I understood what was going on. So,
okay. Number 12, the mean of the distribution of sample means. They're asking what the mean of the sample means is.
mm-hmm.
And that's always the same as the mean of the parent population. Which
Where did you get the parent population mean?
Up above question number 11.
Oh.
The original information, it says the mean of the Idaho students was 3.5.
Okay, that makes sense.
Okay, it's fine. Yeah, that's kind of a pain. Okay, so that one was so easy, it was hard. Okay, so everybody got that? Number 12?
Yep.
Ready to move on? Okay, who wants to do 13?
I will.
Okay, go ahead.
Okay, what is the standard deviation of the sampling distribution of the random variable x bar? The mean of the 81 students who are selected. So for this one, you take the standard deviation divided by the square root of 81.
Right. Christy, do you know how to do these? Number 13? It's just that short little formula. It's the standard deviation divided by the square root of the sample size. Yeah.
Is it 0.007?
Okay, so I just have 0.07.
I must have added something.
So I got 0.077777.
That's what I got.
0.077?
Yes.
I must have added a 0.
But you'll have to round up. So it'll be 0.078.
Okay. Oh yeah. Okay. I know where I did my mistake.
Okay, is everybody okay? I just heard a lot of something crashed anyway. Okay, 2 more to go. Come on, we can do this. Okay. 14, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? So, first we got to find the Z-score.
Yep.
And then put it into the applet, right?
Yep.
Okay. Yeah, because we have a sample. Yes, that's what I'm doing it. Not done yet.
What did you guys get for the Z-score?
I'll be there in a minute.
Okay.
Okay, I hope that's right. I don't want to do that again. Okay, I got 2.5714.
Yep.
Is that what you guys got too?
Yep.
Yeah, this is a little confusing, isn't it?
And then I can't remember the questions.
Oh yeah, we do. I'm sorry. I'm trying to. Okay, so then we have to put it into the applet and find the probability.
The less than probability, right? So we only.
Okay, so yeah, will be less than 3.3. So we're gonna put it in just the. Well, that's not a negative number. 3.
So I wonder if we highlight the middle and the.
That's what I'm thinking.
Oh, you guys didn't get a negative Z-score?
Did we have?
Yes, I did. Sorry. My bad. It's negative. Thank you, Kirsten.
You're welcome.
The Z-score came out negative. So we would just put it in the... One. So we're just going to highlight that little tiny part to the left. Is that what everybody's doing? Okay, so I got 0.0051. 0.0051.
0.051?
0.0051.
Yeah.
Yep.
Yeah.
So we would only 0.005 because we have to.
Round it to 3.
At least it's a good echo. It's echoing what you're what you're saying and not something totally different. Yeah, so number 14 is 0.005. Okay, so number 15 is the same thing, only is it greater than 3.3? So could we just highlight the upper portion?
Yeah.
Wouldn't it be the same though?
No, because you're highlighting the middle as well. You have to highlight everything from the negative z-score over.
Yeah, okay, yeah, that's what Kirsten said. So everything except the little left side.
That's right, because we had a negative z-score. And so then it would be 0.995.
Yes.
Yeah, so 0.995.
Okay.
You're not kidding.
We got one wrong.
Uh-oh.
We got number 5 wrong.
Number 5? Oh.
I guess Christy was right.
Well, Christy, you didn't want to, you weren't on board fully with that, so I guess you can change yours if you want.
You guys could all change it.
Sure. I don't think I'm not going to change mine because that's what I would have answered anyway, so but you weren't necessarily on board with that one. So Christy says that the distribution of the sample means X bar would have a smaller standard deviation, and I just totally don't understand that. So.
You know, now that she says that, that actually was in the textbook.
Dang it.
Why didn't we listen to her? Apologize for us, please.